Hello everyone and welcome to yet another recreational programming session with Mr. Azozin. So I recently noticed that I'm kind of using the same pattern for testing my programming languages like over and over again. So recently I've been working on Tula, my programming language that is based on a Turing machine. So let me actually find its source code. Right, so what's interesting about this language is that it has a bunch of examples and a bunch of tests and stuff like that. And examples are like very small programs. I have like a testing scripts in here. I can just run those testing scripts and that thing will run each and individual test. I think I even have like a file with all of the lists of, yeah, there we go. So here's the list of all of the files that I want to test. What it does, it iterates through the list of all of these files, it runs them, and it actually saves its standard output. Right, it saves the standard output and then it compares it with an expected one. Right, look at that. So essentially I have the file that I'm testing and also I have a file, the same name .expect, it's the expected output in here. Right, so this is an expected output. Right, and what this testing tool does, it just saves the actual output, then takes the expected output and does the diff between them. Right. So, and that's how I know that I broke something in application or not. For example, I can replace this particular line in the expected output to, for example, your mom. We're expecting actually in the first line to see your mom. And let's actually see how the testing tool is going to react to all of that. So let's go, and as you can see, it failed immediately, and it actually uses the diff tool to sort of tell you, like, okay, we expected that line in here, but we got this line in here. So if I change all of that back, right, so I change it to trace, all of the tests will pass, right? So, but the cool thing in here is that if you modified something within the application, you don't have to modify the expected output manually. There is a second script, which is called record.sh, right, which basically runs all of these files again, takes its standard output and replaces the expected output. So I'm not really using unit tests for testing my programming languages. I'm using this like sort of like integration test, right? So I'm looking at the language as a whole. I'm not testing specific units, right? Because I'm usually very experimental with the languages. I change a lot of things, and doing unit tests in like a TDD style introduces a lot of friction. So these are called snapshot tests, right? So there is some sort of like a official name for that. The thing is that with the testing terminology is that it seems like there is a standardization of a testing terminology, but this is actually an illusion. Like every project, every company uses their own terminology, right? And if you move between different like teams, between different projects and the companies, you have to relearn this terminology again. Some people call it behavioral tests, some people call it integration test or whatever the fuck it is, right? So the terminology intersects a little bit, but not really, right? So yeah, I like to look at the thing as a whole, right? So because it allows you to test things, but doesn't impose too much friction to experiment. Right. So I feel like this extensive like a TDD style testing is needed for like security critical applications, like I don't know, encryption libraries or something like that. It's just like a very heavy process, right? So where mistake has a huge cost. So in my, bullshit toy applications, like the cost is actually very small. So it doesn't matter. So I rather prefer to have less friction. But at the same time, like sometimes I can break something in another place of the application while working on a different end. Right, so that happens. And this kind of stuff is very convenient, right? So I modified something, I did some tests, I re-recorded everything, and there we go. I'm good to go. I continue working on some other things. Right, so this idea didn't really start in Tula. This idea actually started back in Porth, right? So do you guys remember the Porth programming language I developed back in the days, right? So when I was younger and more energetic and world was not going to shut completely, yeah, so I was developing Porth, and this is where I got this idea, right? So that I want to do it like that. So there I actually had a test.py, and I was originally kind of thinking to implement this testing tool in Porth eventually, right? So, and if I try to run this entire thing, right? So it kind of works in a similar manner. Right, so there's some tests, there's also some examples, and near the examples, as you can see, there are txt files, right? So I have a bubble sort, right, bubble sort.porth, and then I have an expected output in here. An expected output is actually in a very interesting and strange format, right? When I was kind of preparing for today's stream, right, I just look at this format and I don't remember. Did I come up with that format or did I steal that from somewhere? Does anybody remember? People who watched all of the Porth series, where did I get this? I came up with this format. Really? I came up with it because I looked back to it and I feel like that I stole it from somewhere. I feel like I stole it from somewhere, but so yeah. So and you guys even remember the argument for this thing, right? So I developed this format to actually make it easier to implement in any language, right? So the thing that I remember is that this format looks like a text format, but it's actually binary format. So it's a binary format that disguises as a text format, and there's actually a very specific reason for that, right? So essentially, as of right now, in that format, you have two kind of fields, integer fields and binary blob fields, right? So I suppose just binary fields, or I think they're blob, right? In the code, I call them blob, right? And essentially, each field is a line. Right, so essentially you read the first line and that's the field. The type of the field is denoted by this prefix in here. So :I means it's an integer. Then it is followed, I think it's strictly followed with one space. It is because it's a binary format. It's strictly followed by one space. Then the name of the field, right? So it's a key value, right? So here is the name of the field. And then you have the integer itself, right? This is the integer itself. So this is the first kind of fields that you can have, right? You can have named integers. So the second kind of field you can have is blob fields, right? So they have prefix :b, then they have the name, and then as the integer value, they have the amount of bytes, like how many bytes there are in that blob. So then comes the new line. And after the new line come the bytes of that blob. And then at the end you have additional new line and you continue as usual. Right, so for example, here I have a blob with the name standard output that contains 154 bytes. Then after the new line come the bytes. Right, and after the bytes you have an extra new line and then the next field. That's the entirety of the format. Like literally there is nothing else in here. And I'm using this format in Porth to actually store information about the expected output, expected behavior of the test, right? So here I say that for the input, I don't provide any additional arguments. For the standard input, I don't provide anything. The return code is expected to be 0. The standard output is expected to be this, and the standard error is expected to be 0. Right. And this format is extremely easy to parse, right? So it is extremely easy to parse. Let's actually take a look at it. So let's open test.py, and it's like contained entirely within this entire thing. There we go. So essentially, you just have to open the file as a binary file, right? And if you want to read a specific field, right? So if you want to read a blob field, so what you essentially do, you essentially just do that. You read the line, you like basically test that the line is blob with that name, and then you get the size and you read this amount of bytes, right? And there we go. And then you return this entire thing. To read an integer field, you do that. Right, and then there is a couple of functions to write integer fields and to write blobs. That is basically, this is the entire parser and the serializer of this format. Right, so 24 lines in Python. Right, and I'm pretty sure like it's so simple you can actually implement it in C, you can actually implement it in like in Java, in C Sharp, whatever. In Haskell you can implement it in Haskell. Haskell actually is quite convenient for parsing binary formats, surprisingly. Erlang also very convenient for this kind of stuff. So and like what's the point of inventing this weird format? Right, so essentially the output of the programs can be kind of like arbitrary, right? So it can be arbitrary, so it has to be something binary. And if it's not binary, you have to invest into escaping those binary outputs and stuff like that. So it's a huge pain in the ass. But at the same time, if the expected output changes, I want those changes in the expected output to be reflected nicely in the diff of the version control system. You know what I'm talking about? You know what I'm talking about? Right, so essentially the expected output changed some of the word in some of the line. And that modifies the expected output file. And since it basically lays out this expected output as text, it looks like a text, the diffing tool will actually show that properly. Right. If it was some sort of a JSON, especially if it was some sort of like a minified, not pretty printed JSON, it probably will look horrible and it would be kind of difficult for you to inspect what kind of expected output changes throughout the history of Git. Right. So this format is actually very carefully thought out to be the way it is. Right. So there was a lot of kind of technical limitations that I imposed on myself for this format, and this is how I designed it. Right, JSON looks like shit. Yeah, so the thing about JSON is that it's kind of like yet another manifestation of a Stockholm syndrome. Oh shit, YouTube people probably don't know what the fuck I'm talking about. This is something that we talked in the press stream, right? And by the way, for YouTube people, there is a lot of extra content on Twitch that you don't see, right? So we have a pre-stream, like a 10 minutes where we just like talk about different stuff and stuff like that. All of that is usually cut out from the YouTube, right? In the pre-stream, we talked about a server-side JavaScript, right? So, and I said that server-side JavaScript is just the ultimate manifestation of Stockholm syndrome, right? Because there's no reason to use JavaScript on the server, right? So you kind of forced to use JavaScript on the front end because the only thing that works on the front end is JavaScript. But on the server, you can use whatever. You can use actually useful language, right? But you decide to use JavaScript. And because of that, for me, it's an ultimate manifestation of Stockholm syndrome, right? So the same with JSON, right? So dude, like, could you please fucking stop? Seriously, like, people who in this conversation bring up WebAssembly know fucking nothing about WebAssembly. I swear to God. It's just like it's just the only reason you bring it up is that you probably heard somewhere on Hacker News, oh, WebAssembly will help you to replace JavaScript in the browser. How is it going to do that? What are the technical details? Who fucking cares? It's the big new thing. It's like, stop. Fucking stop. Read more about WebAssembly, read specification, learn what it actually can and cannot do, and stop shoving it everywhere. It does not replace JavaScript. Please. It's just getting annoying. So anyway. So to actually be useful, WebAssembly needs shit ton of JavaScript. It needs shit ton of JavaScript. It's fucking insane. I'm telling you. So anyway, what's interesting is that this kind of tool that basically does the behavioral tests, it's kind of useful not in a single place, not only a single place like Porth, right? So it could be useful in Tula, or maybe in the future I'm gonna develop other like a batch programs, so, and it could be useful there as well. Wouldn't it be cool if this test.py was a self-contained, its own like a behavioral testing tool that really doesn't care what exactly it's testing, right? It just runs a specific command, takes the expected input-output, just compares it and tells you like what happened, right? And it really doesn't care what exactly it is testing. So, and it's using this special format. I didn't even come up with a name for this format. right? I need to come up with a catchy name and cute mascot for this format. So then I can sell merch and stuff like that and create a cool website, right? Look, it's a new fucking format. It's so fucking simple. Here's the spec and 24 lines of Python. Buy my merch. So I'm sorry. Yeah. So maybe I need to sort of somehow formalize this kind of format. So maybe it could be useful, not only for testing things, because I can see this format being actually very useful because you can have nested structures in this format. Actually, so it looks like a linear format where you just have like a key value, key value, key value. But who said that it could not be recursive and you cannot store additional thing, like store the same sort of structure within a blob? Think about that, right? Because blob just stores arbitrary binary data. Who said that within the blob you can't have the same format in here? Right, so you can actually nest them, right? So you can have a tree. You can store an actual tree in here. So yeah, so I can see that being useful. So people are already coming up with the name for this format. I'm not really sure how to call that. So real tree, yeah, real tree, like actual tree that you, like in Minecraft, right? That you have to punch or something. So, but maybe this format is not particularly useful because it doesn't really have like sophisticated, like more different types. What kind of other types would that format need, right? So something like float could be added in there. String could be just a blob. So yeah, and then if you want to have arrays, well, you can actually have arrays, right? So you can just store the keys sequentially, right? So for example, here we kind of have array, right? It's kind of a dumb array, but I mean, yeah. Yeah, it's kind of cool structured format. I think it needs to be like a formalized somehow. So here we have some sort of, oh yeah, so this is the output. Yeah, you can see that. So yeah, what I want to do, I want to take this test.py and turn it into more universal testing tool. So I decided that I'm going to call it Riri. So, and it's going to stand for record replay, right? So it's a tool for recording the behavior of certain commands and then replaying them. So the idea is going to be that you're going to have something like tests list, right? So this is going to be test list. And test list is going to be just a list of shell commands, right? Something like a cargo, run, right? And in case of, for example, Tula, right? So there's a run subcommand within this entire thing. So you do run, and some sort of like a hello Tula example. And you have a bunch of these things, right? Like, for example, fizzbuzz, or Fibonacci, and so on and so forth, right? So this is going to be something like this. Then what we're going to have Riri, and I really want this Riri to be sort of like a self-contained thing, right? I really want it to be a self-contained thing. So then you can copy paste that entire script in your project and just use it, right? So the only thing we're going to be using are the batteries, whatever comes with the Python distribution, right? So probably not going to use like you know, pip or like what is the like stuff that is used by Python these days. So there's usually requirements.txt, right? You install the requirements.txt through pip. There's also virtual environments. There's also alternatives to virtual environments because like there is some sort of a competition between communities. There's some sort of like a shit show going on in Python. It used to be very simple. You would just download Python. It would have like everything you need. Yeah, so Python is a huge mess. Like there's also Conda. Yeah, I fucking remember that. Like holy fuck. So it's kind of bizarre. Like if you Google a Python, right? So on Wikipedia, right? So just Google a Python. So Python genius, right? So is there, okay, Python programming language. If you scroll, I really like a good one, awesome. Okay, so maybe they already removed that. Maybe they already removed that, but there was a thing. Battery, yeah, batteries included. Yeah. So it's often described as batteries included language due to its comprehensive standard library, right? So it was like a huge part of its marketing. So batteries included was a huge part of the Python marketing, right? So you would download Python distribution and that's it. That's the only thing you will ever need, right? No package managers, no environment managers, or none of that bullshit. Like you just get the Python and that's it. So, and now it kind of faded away. Everyone kind of got infected by the web disease, by the NPM disease, and now all of that has to be a lot of different fucking left pad packages or whatever the fuck it is. Right, so I don't fucking know. Anyways. Yeah, so, and this is going to be a self-contained script, right? And essentially what you would do, you would probably do Riri, then you would do maybe like replay test.list, right? You would do replay test.list, and it would go through all of the commands and will just run them and then compare them with expected outputs. And then maybe if you want to save the expected output, you do record, right? So you do Riri record and then replay. So this thing is going to have only two subcommands. And as the format for storing the expected outputs and expected behavior, we're going to be using that blob format, like BI. Maybe I should call it BI because there's two fields in there, B and I. BI format, right? So sounds good actually, maybe. I don't freaking know. So I don't freaking know. I don't freaking know. So there's something already. We have a competitor. All right, so I'm gonna sue them. I'm gonna fucking sue them. So R does, it's primarily C++ debugging tool for replacing, well, what? Aspires to be your primary C++ debugging tool for Linux, replacing well in... What are you talking about? Have you watched the stream? Like, anyways, right. So let me actually start doing this entire thing. So how do you program in Python? Does anybody freaking remember? I think you have to do some shit like if name equal main, you would do something like this, right? So something like hello world, right? So hello world. Let's actually try to maybe also make this entire thing executable. Oh, by the way, eggs. Weren't like packages in Python called eggs? Because it's a snake, it's a Python. Right? I forgot the semicolon. I'm really sorry about that. I forgot the semicolon. Yeah. So I kind of remember that. Do people still use that word? Because I rarely hear the word egg. Oh, it's in chicken scheme. It's not in Python. Right. So because okay. Chicken scheme. Let me see. Yeah, so call CC. Yeah, so it's basically like a variant of Lisp, and packages in this variant of Lisp, they're called eggs, right? So, but I'm not sure about Python. So. Anyways, who programs in Scheme these days? So let me try to run. Okay, there you go. So here's the hello world. So, and the reason, if I remember correctly, why the fuck you have to do it like that, so this kind of code is not executed when you load this file as a module. Do I remember that correctly, chat? Do I even remember that correctly? I think I do. Right, because you can do something like Python 3, you can try to import Riri, right, and as you can see, it was not executed, but if I didn't have that line, right, if I didn't have that line and I tried to do something like this, it would actually, yeah, it tried to execute that, but I mean, it failed because I have this extra indent, freaking Python. Yeah, there we go, and it executed it on import, so it basically evaluates everything unless it's behind this like a if statement or something like that. If you never knew that, now you know. You probably know that already. Like everybody knows Python. Python is the most popular programming language on planet Earth. Everybody knows Python. Even your mom knows Python. So anyways, so we need to parse the command line arguments. So who remembers how to parse command line arguments? I think there was something like argv. Yeah, so there we go. So there's an argv. So if I take a look at the argv, so there is nothing in there, right? There's literally nothing in there. I can actually import sys, and then maybe I can import sys argv. There we go. So this is a sys argv, and if I try to run it, so here is the program, right? So here is the program name, and if I pass something like full bar, right? So all of these arguments are available in here. Okay, so that's pretty convenient. So that is in fact a pretty convenient. So I remember there was like a way for me to pop things out, right? So I think it was something like this, right? So if I now take a look at that, so this is a program and this is argv, and if I try to run it, there we go. So I managed to kind of like split it off. So I popped it out of the left, and now as you can see, I have just like a program name separately in here. So this is a program name. Now I can try to parse the rest of these things in here. So we're going to have like a subcommands in here, right? So we're going to have a subcommands. So that means I need to first check if len argv even has anything. So if it's equal to 0, we have to sort of like a say, bruh, you didn't provide a subcommand, right? So let's actually do something like this. So this is going to be error. No subcommand is provided, right? So no subcommand is provided. We have to do exit with non-zero exit code, right? So there we go. So and then we can have subcommand argv, and this is going to be just another argv. Right, so and then we can just do what? We can print the subcommand like so. Yeah, so the subcommand is full. Right, if we didn't provide any subcommand, no subcommand is provided. Right, so maybe it would make sense to print the usage. Right, so the usage is going to be, maybe I can use f strings. Look at that, right? So do you guys know about f strings? That's actually super cool. Right, so what I have to say is program name, right? So program name, subcommand. Actually, it's mandatory, so we're gonna say sub command. So this is a mandatory. There we go. Look at that. It even like does everything correctly, right? So it copies exactly the program name that we used, right? So you know how to use all of that. So that's pretty cool. So and now what we can do in here, we can just do a switch case. Does Python have already switch cases? Did they already introduce switch cases? Because the last Python that I tried was Python 2, right? So match cases. Okay, it's from 3.10. Do I even have? Oh, okay. So I do have 3.11. Okay, so let's actually Google it up. Python match cases. Match cases. There is a matching now. So where is the philosophy? There is only one way to do that. What Python turned into? Batteries included. There's only one way to do that. Where is all of that shit? Guido and Rossum left and you instantly filled Python with bullshit. Literal children, like an actual adult came out, like went out of the room and you instantly turned everything into a circus. What a shame. Anyways. So let's take a look at the match cases. Kind of sad. Yeah, exactly. All right. Why this is not just a single example and that's it? Why does it have to be like a wall of like? I don't fucking care. Like I don't fucking care about any of this shit. All right, just okay. So match command. Okay, I see. All right, so let's give it a try. Match. Yeah, CEO. SEO, I think that's what it is. It doesn't highlight shit. Bruh, my Emacs is old. What the fuck is this scheiße? Okay. Okay, it doesn't even highlight case. All right, so we can have subcommand and replay. And then 1, 2, 3, 4, print to do replay. And what else do we have in here? Replay, record, right? So replay and record. So, and there's also other, we can here print maybe, it doesn't even indent everything properly. We're gonna say something error, unknown, subcommand, And maybe we can even put F in here and then exit with non-zero exit code. So let's see if this is going to actually work, right? So I'm going to do foo. Oh, it's a case other. All right, so let's do it like that. It's a case other. All right, a known subcommand. And then if I do record, it's going to be just that, and replay is going to be just that. Man, it freaking sucks that it doesn't highlight this shit. Right. Let me actually take a look at Vim. Maybe it's going to be better in Vim. So can you make it better? I can't make it better. Okay, so let me try to take a look in Vim in here. So it's going to be ft Python. So there we go. Match. Even, okay. So, all right. So I suppose we're going to be using old ass Emacs. Or, you know what? Fuck you and your latest Python bullshit. Fuck you. This is the Python I remember. There's only one way to do that. Fuck you. I'm gonna be using if and else if. I'm gonna be doing that. I'm gonna be doing that. And there's nothing you can do about that. Even I'm gonna upload it to GitHub. And I'm gonna close each and individual pull request that suggests to use match cases. I'm gonna close all of them. Like, I'm not gonna accept them. That's it. That's it. You ruined Python. I'm not gonna let you ruin my project. Anyways, so let's continue. So replay, record, and I was going to do a record. Else, and in here we're gonna be doing what we're gonna be saying it like that. There we go. So we have subcommands in here. So the first thing we're probably going to be implementing is record, right? So because we need to implement these things. Man, it's so inconvenient to actually change their order, right? Because if I want to do it like that, it's kind of like, but no, I have to be determined, right? So we're not going to be using match cases. And also, let's not forget semicolons. And if you submit the pull request that removes semicolons, I'm going to reject it as well. I'm going to reject it. So semicolons. We're going to be using semicolons and we're going to be using else ifs. You don't like that? The code works. The code works. Right. So you just bike shedding. I'm an artist. I see that way. Okay. So when we're going to be doing records, we have to accept an argument. So I suppose what we have to do in here is something like a test list, right? So test list. To be fair, we have a limited amount of subcommands. Like I don't plan to have more than 2 subcommands in here, so we can just say record or replay, right? So it's a record or replay, and then you have a test list in here, right? So it's going to be a list of shell commands. It's going to be a list of shell commands that you're supposed to run. Remember their output and just like you know, check if it's correct or not, if it's expected or not. So in here, what are we doing? So we expect the input file, right? So we're gonna do if len argv is equal to 0. What we're gonna do? We're gonna print right usage. We're probably gonna do program. To be fair, maybe we have to, since both of the subcommands are gonna be accepting the file, at least for now, I'm going to be just parsing it for both of them. So we expect subcommand and then we expect the input file, right? So I guess that's fine. So here, it's going to look weird if I do it like that, right? So it's going to look weird, for example, because if you have an incorrect subcommand, right, and but you didn't provide the input, right? So it's going to basically say usage incorrect subcommand and then the file, so it's gonna look kind of weird. I really don't like that, so probably not gonna do that. I'm sorry chat, we're not gonna be doing that. Right, so it kind of makes sense, but it doesn't really, you know, save anything. So in here we're gonna have a test list, right? So this is the usage, and then we can say no test list is provided. provided, and then we're going to exit with non-zero exit code. Otherwise, we're going to do something like a test list path, right? And we kind of extracting that from the arguments, right? So we extracted that from the arguments. And the next thing we need to do, we need to read that file. Does anybody remember how to read a file in Python? Okay, so let me see. I remember that there was something like help open, right? Okay, so yeah, there we go. So open a file like a normal, and yeah. Okay, so you by default it's opened with read, and that's exactly what I want in here, right? That's exactly what I want. So, and if I remember correctly, you also use this with syntax, which is basically array right? So resource acquisition is initialization, right? So that means then you go outside of the with block, it will automatically close this entire thing, and so on and so forth, right? So I kind of vaguely remember all of that from my Python 2 and early Python 3 days, right? So with open, and we provide a test list path as f. Right, and then you just kind of like do that. I wonder if I can just explore the file thingy. So if I do open, do I have the file? Okay, so it's actually called, for some reason, tests, not the test, right? So maybe I should actually rename it to test, right? So I'm gonna open this entire thing like so. Here is the open file. Let's take a look at its inner help. Right, so it's text.io wrapper, but I mean, it's too much text. So let me take a look at the dir of this entire thing. What kind of things do we have in here? Do you have like a, okay, so it has a read line, so I can literally just say, okay, read a line for me. Read that line for me. Read that line for me. Okay, so so what we're going to be doing now is, can I now... So when do I stop reading this entire thing? When do I stop reading this entire thing? Okay. Oh, okay, I can actually read lines, just read lines. So that's pretty cool. Yeah, that's pretty cool. So I can do F, read lines, and then for line in read lines, I can simply print each individual line. Look at that. And don't forget the semicolon, of course. Let's not forget the semicolon. Okay, so yeah, so I'm gonna do record, right? So this is the record. No test is provided. Okay, so let's actually provide test list. And there we go. As you can see, it did that. Isn't that a poggers? Isn't that a poggers? I think that's pretty freaking poggers. So people say that line in F, so the file is iterable. You know what? You know what? I'm not going to be doing that. I'm not going to treat file as an iterable. And if you submit a pull request that changes this beautiful 4-line in read line, I'm going to reject it. I'm going to fucking reject it. Straight up. Sorry if that offends you, but that's the Python I remember. So anyways, Alzheimer. So yesu. I'm actually kind of curious. Will it work? Well, let's give it a try. It still works. Okay. I'm going to be using it like that. We're going to be using it like that. So what do I want to do with this shit? I want to kind of run it as a shell, right? So I want to run each individual command as a shell. How can I run thing as a shell? I remember in Python, with my Python Alzheimer, that there was a shit called subprocess, I think. Yo, what the fuck? The following documentation is automatically... It feels like it's written by Lex Friedman. I swear to God. The following documentation is automatically generated from the Python source file. It may be incomplete, incorrect, or include features that are considered implementation detail and may vary between Python. But I still love you all. Anyway, so what do we... How do you, if I have just a shell command, how can I run it just as a shell command? So I know that the Python website has a pretty good documentation, which is usually better than the help thingy. Right, so Python subprocess. Yeah. Subprocess. System, nah. I think I know what I can do. I think I freaking know. So there's also popen. I think I want to actually directly call sh. Right, so the way you do that, you just provide it like that. Or, yeah, so command exit, so it explicitly says that it does not parse the shell stuff. Right, so it doesn't understand if it's a shell command. But what you can do, I believe, meine Freunde, subprocess, you can basically do the following thing. So subprocess run, and you can do sh -c, right, -c, and then the line. That's what you can do, I think. I think that's what you can do. So, and yeah, let's give it a try. So, yeah. So sub command, str object has no attribute. Are you freaking serious? Sub process. Jesus Christ. They both start with sub, okay? So sub process. Don't judge me. Yeah, let's go. Could not find. So, I mean, they failed. They freaking failed. But at least it tried to run them. So this is the output from the actual cargo, right? It's an output from actual cargo. And to be fair, maybe I can do some things like, I can probably use echo, right? So echo hello world, right? So because we're testing these kind of things, then foo bar, right? So your mom. All right, so that's basically the things we're going to be doing in here. That's basically the things. And surprisingly, let me just run these things because I feel like the last command is a little bit weird. Right, so did it perform 3 of those things? So since it kind of includes the new line, so the last line is not really considered as an empty line. Yeah, it's not really considered as an empty line. Okay, so that's cool. I don't have to worry about that. All right, all right, all right. So it's a really well thought out, I would say. It's a really well thought out thing. Okay, how are we going to be actually doing all of that? So in a subprocess, let's actually learn a little bit more about the subprocess run. So subprocess run. So what does it have? Okay, so you can do capture output. Okay, that's pretty cool. So it also has a shit ton of key values. What does W stands for? So the key arguments, but I know what they are. I know what they are. So keyword arguments. Oh, it's like it's a abbreviation of a single word. Okay, that makes sense. So I know what they are, right? So it's optional things that you just do name equal value, and so on and so forth. Key value, yeah, key value. Right, so that's how it works. Thank you so much. I remember there was more shit in there. Well, I mean, yeah, so the more shit in there is probably in there. Right, so maybe we can find documentation for the run. So sub process run. There we go. It's kind of funny that the website, the docspython.org, usually has more information than the help of the actual interpreter. It's kind of bizarre, isn't it? Right. So it's kind of bizarre. So what do we have in here? So we can specify standard input, standard output, right? So let's read about capture output. What does it do? If capture, so can we actually set the, dark mode? Okay, we can. I'm not flash banging you. Flash banging you. Okay. So if capture output is true, standard output and standard error will be captured. Okay. So when used, the internal popen object is automatically created with the standard output and standard input both set to pipe. Both set to pipe. It's all capitalized for some reason. The standard output and standard error arguments may not be supplied at the same time as capture output. If you wish to capture and combine both streams into one, set stdout to pipe and the stdout to stdout. Okay. So this is a pipe. All right. So you're capturing the output, and the capture output by default is actually false. Shell check. I want to kind of capture it into a buffer. But anyway. Whatever. So one of the things we probably want to have in here, we probably want to have an object that stores basically the results of running all of those things. And we can say, so this is going to be a capture, and I think it should be the list, just a regular list, and we're going to be iterating through all of this thing, and we're going to be appending that to the capture, right? And each instance in that list is going to be a dictionary. That dictionary is going to include let me see, it's probably going to include the shell command, right? So whatever was in that specific list, right? So for example, this specific thing, right, like so. Then it is going to include stdout, what this command is supposed to print, like so. Then it's going to include standard error, like so, and also return code. Right, so this is going to be basically a list of these sort of like a dictionaries, and then later we're going to dump it into that by format, right? So we're going to dump it into that by format. That's my idea. So, but the first thing we need to do, we need to kind of run this entire thing, and to be fair, maybe it would be better if that was some sort of a function, right? So capture, right? So here we're going to accept the shell, which is going to be a string, and we're going to probably return some sort of a dictionary. I wonder if we can just say it's going to be a dict, right? So I don't want to specify what exactly going to be there, but I'm just going to say it's a dict. Can I say something like that? Maybe I can. Right. So in the way we're going to be doing that, all right, so this subprocess thingy is going to be basically part of that, right? So it's going to be part of the capture. And what we're saying in here is just like, okay, capture, let's call it snapshots, capture line. So this thing is basically shell, right? Capture shell. So how do you append things in Python, right? So if I have access, can I do append 69? Okay, I can. So the thing about Python is that it's kind of like self-explorable and it's easy to experiment with. So this is one of the things I think Python developers like did right. Right, so at any point you can always just do dir and just inspect what kind of fields you have in here or methods, or maybe even take a look at the help. Right, so this is actually like super cool. I think this is one of the things that made this language popular, right? So because it doesn't feel like a programming language, it's an interactive environment, right? So what does dir stand for real? I suppose they were trying to mimic the dir from Windows or DOS, right? So in DOS originally, there was a dir command which would print the current folder, the current directory. It's basically analog of ls, but in this normie world, the world of DOS and Windows, like it's ls but for normies. That's what it is. And Python, by the way, originally was developed for DOS. Not everybody knows that, but Python is an insanely old language. It's an insanely old language. Python 1 was developed for DOS, right? So it's supposed to sort of mimic the CMD, like the command line of DOS. They just decided to call it dir, right? So because objects are like folders, right? You look inside of the folder and you explore it, like from 1991. Yeah. So, and as far as I know, in the early 1990s, DOS was the most popular operating system, right? And Windows was not even an operating system on its own. It was just a desktop environment on top of DOS, right? So you would install it separately to have the graphical interface. That's how it worked for a long time. So yeah, so that's probably where it's coming from. Good times indeed. I do agree with you. So snapshots, append. Was it append? Yeah. So I think I did append. Yeah. Yeah, it was append. Cool. And that's basically the idea. So now I can chat. You know what that means. You know what that means, chat. I can do some shit like for shell in F. Okay, I'm not gonna use read lines because it makes it shorter. All of the CS students are fucking coming right now. Fuck, holy sh, is that a least comprehension? What the fuck? Anyways, I wonder, can I just do some stupid shit like this? Will that automatically close the file? Can anybody tell me, or will it not? It won't close the file. No, people, oh, fuck. But I mean, the reference to this file will be lost, and will it be garbage collected? And when it will be garbage collected, will it be closed? My neighbors are doing fucking something. Anyways, so let's actually do the usual with as f. There we go. And I want to kind of initialize it first so it exists, and then I'm gonna just do it like that. So that's much better. So, and after that we can just basically dump snapshots, right? So snapshots, and we can dump them into something like tests bi, right? Or maybe it would be even better to actually make it based on a test list path, sort of like .bi. So, and obviously I want you to actually do something like this. Right, so the only thing we need to implement right now is just these two functions. The first one that captures all of these things, and the other one basically dumps, right? Dump snapshots. So this is snapshots. We were accepting the file path as the first thing. So this is the first thing, file path str, and snapshots is basically a list of dictionaries. I don't know if it's going to work or not, but who cares? So, and here I'm going to put a pass in here. All right. So can I just do something like throw or rise not implemented, right? I think I can do that. There we go. So we can just say that all of these things are not implemented. So if I try to run all of that stuff, okay, so it failed at not implemented. And if I go to 8, yeah, so it actually failed in here. So that's pretty cool. So yeah, I'm already streaming for 1 hour. I ran out of tea. I didn't even have tea at the beginning. So list, so I have to use like a list. To be fair, I don't really plan to use my pie as of right now. So what I'm doing in here, I'm kind of just documenting this kind of stuff for myself, right? So that's what I'm doing. But maybe in the future, I'm going to be using my pie. I don't even know if I have my pie installed in here. I do have, well, wait. This is so funny. My pie as a command does in fact exist, but then apparently it is trying to open my pie module, and it fails to do so. I don't know what to make up of that, but I mean, maybe I have to install something like pipe3 install my pie. I can try to do that. So is it pip? It's not even a, okay. I give up. Whatever. That's literally why I want you to make this script self-contained. So none of that situation will happen. Okay. So we're only going to be using batteries, right? Because I think that's a good approach. So I wonder if I do this kind of thing and import pip, right? No, that doesn't recognize any of that shit. That's bizarre. Maybe I just like don't have it. Maybe I have to install it separately. Let's give it a try. All right, so I'm gonna do sudo and let me quickly mute myself. All right. So yeah, it does. It's not available on Debian. Anyway, so none of that matters. None of that matters, honestly. What I need to do, what matters? T. T does in fact matter. So let's make a small break, and after the break, we're gonna continue working on this entire thing. We're gonna learn how to capture things, how to run things, and so on and so forth. All right. Okay, so let's go ahead and just run this shy soon. So what we're gonna do? We need to capture the output, I suppose. Capture the output. Line. So the first thing in here is the arguments, which is understandable. So then we capture the output, capture output, and this is going to be true. So can I do some stuff like this? Is that an LE? Oh, okay, looks like it's allowed. Looks like it's allowed. Right, let's go ahead and just like do that. So what do we have in here? So snapshots, it didn't like that. It didn't like the line because there is no such thing as line, there is only shell. Right, so what else do we have in here? Looks like it actually managed to run. By the way, does it return anything? Maybe it returns something. So you do examples, so you do process, and it's okay. So it give okay. That's actually super cool. That is actually super cool. Right. So that means I can do something like a process, but it would be also nice to kind of know what you're doing in here. So let me maybe start the Python, maybe even import subprocess, right? So let's actually import subprocess. And within the subprocess, what we're going to be doing, can you see what I'm doing now? You can see what I'm doing. So we can say, so it's shc echo your mom. Right, so here's the capture output, and we have a process. And what do we have in there? Ooh, okay, so we have a standard output. That is very cool. I really like that. So that means I can just do std out, right? So this is std out. Then I have return code, which is a 0, and standard error, which is like not. Okay, that's basically everything. Right, so it's that easy? It's that freaking easy? I didn't expect that. Anyways, so that means after this entire thing, we can just return the thing. So this is going to be shell, and I'm going to just do it like this, shell. And afterwards, I want to have the standard output, right? So this is the standard output. We're going to take it. So is it blocking, by the way? Right, I'm pretty sure it is blocking, which is fine. So, and if it's blocking, there should be a way to say it's non-blocking. Timeout, check, encoding, errors, text, environment, run the command, wait for command, and then, okay, so it is blocking. So wait for the command to complete. Okay, that's cool, that's cool. Everything is working exactly as I want it. Everything is working exactly as I want. And here we have a return code. Return code. There we go. So we have a bunch of those things. And in a dump snapshot, at least for now, we are going to, I can't select it for some reason. We're going to just print this entire thing. I'm going to just do print snapshot, snapshots, and let's actually run it. Okay, so these are the things that we've got, right? So we have the shell, right? Associated shell in here. So the standard output is that, return code is 0, then that, and so on and so forth. Okay, so we successfully implemented the capture command. So it, like, I expected it to be a little bit bigger, right? So maybe I can just inline it then, right? If it's that simple. But at the same time, it will not allow me to use list comprehension and earn respect from CS grads, right? So, because that's the only thing they respect. They respect you knowing some obfuscated, you know, comp soy features. They don't respect you if you actually made something working, right? So they don't give a fuck about working software. They only care whether you know what is a monad or how to use list comprehension, right? So that's the only thing they care about. But anyway, so what we have to do in here, now we have to actually like serialize this entire thing into the format, right? Into BI format. So I'm gonna steal, I have a PyCache in here. What the fuck is that? What the fuck is this scheisse? It's probably, this is where it keeps all of this stuff like compiled or whatnot. But anyway, so let me go to maybe test.py. and just steal everything related to kind of, you know, reading and writing this format. I think it's going to be useful in the future. Right, so blob fields and stuff like that. So they all accept binary IO, right? So they all accept binary IO, which means that you have to open this thing in a certain way. So you have to open it as a binary. So this is something that I will have to keep in mind, right? And we also actually import a lot of different stuff in here. So, but we can just do the following thing. I can just try to run and see if it's going to fail or not. Yeah, there we go. It cannot find binary IO. Let's actually go ahead and just import this entire thing like that. Is it going to work? Yeah, it is working now. It is working. So maybe it would be nice to indicate what we are recording right now, right? So maybe we can basically print something like capturing shell, right? So this is going to be shell, and we can put a triple dot in here. Jesus fucking Christ. Did you hear that? Did you hear that, guys? My neighbors are doing something. And it's a fucking middle of the night. You fucking drunk motherfuckers. Okay. So if you take a look at the documentation for print, can I say, okay, so yeah, you have end, which is by default the new line. So one of the things we want to do in here, we're going to just say there's no end in here. That's bizarre, honestly. The problem here, okay, so the problem here is that the shell itself contains the new line. So can I maybe trim the whole thing, right? So if I have something like this, hello, right, so with a bunch of spaces, right? So I have this kind of thing. Can I just trim this motherfucker? Did you mean wow, what the fuck? Actually useful error messages? What the hell? So strip, okay, yeah, all right, so we can use strip in this specific case. And I suppose maybe the way we're gonna actually do that is by using strip in here. So now it's a little bit better, right? So capturing, yeah, so capturing echo hello. All right, so maybe it would be better to actually put backticks in here so we know the boundaries of the command. Okay, so capturing hello world, echo foobar, and so on and so forth. That is very cool. That is very cool. So afterwards we are we need to open the file, right? So let's do with open file path. We're going to be opening it for writing binary. We're going to open it for writing binary as f, right? So as f. And we're going to just iterate through the snapshot. So snapshot in snapshots, like so. And for each snapshot, how we're going to go about that? That's a very cool question, I think. We need to... Yeah, we can just probably save everything sequentially. So we're going to say shell, standard output, standard error, return code. Shell, standard output, standard error, return code. Or maybe return code is going to go first. I don't really know, right? So it doesn't really matter that much. Write blob field. So, and we have to actually convert all of that stuff to bytes. Right, so here I'm going to specify f. The name is going to be just shell. The blob is going to be snapshot shell. Right, so it's going to be snapshot shell. But it's going to be a string, which raises the question. So do I convert it to bytes myself in here? Maybe this is what I have to do. Right, so if I have a string, something like s strip, if I want to convert it to bytes, do I do it like that? Or do I do it like that? Or do I do it like that? Okay, so chat, who knows? Who's going to be quicker, Google or you, chat? Okay, you're going to be faster because I spilled a little bit of tea. In code, okay, so you were faster. All right, but this is because I spilled a little bit of tea. Okay, so that's why it's actually, oh, okay, so it's bytes, but you have to also specify the other thing. Well, no, it's not that. Where did you get that shit? Oh, okay, so that seems to be working. But I mean, what if I just want a bytes encoding? What if there's no encoding? But maybe that's fine. Maybe that's what we want to do anyway. So UTF-8, like so. So this is bytes basically. So this is a shell, and so we're writing it as a blob field. Then we need to write int field, which is going to be return code, and in that case, it's going to be return code. Then we need to write another blob, which is going to be standard out, and in this case it is already bytes as far as I know, right? So we don't have to do anything in here. So this is the std out, and then in here this is the standard error. There we go. So that's basically it, right? So we're writing all of these things in order, and there we go. So let's go ahead and see what is going on here. So required be a bytes-like object or object that implements bytes. All right, so where exactly did it fail? Oof. Oh, so name, okay, I see what is going on. Name also has to be the bytes. Okay, so that explains it. Where is, okay, I see. One more time, there we go. So it created test list by. And now if I open it up, so here is the output all serialized. What's funny is that like the format is so freaking simple. I already serialized like everything, and it's not difficult to parse it even in assembly. I think this format is even assembly friendly, honestly, right? So you can implement the parser in assembly. That's how simple it is. Right. So did I say std in, or what do you mean std in? So we don't really save std in as of right now, but we may in the future. We'll see. But if std in has to be part of the test list rather, right? So I think that's what it has to do. So test list. Next episode is testing framework and assembly. Exactly, that's what we're going to be doing. All right, so we implemented record. Seriously, we just implemented record. So now we need to implement replay, right? So let's go ahead and try to replay test list. There we go. So it's not implemented. How are we going to be going about that? So what I expect is the input in here. So we're going to be doing like kind of a similar thing. Yeah, so we just need to open the file one more time with open. To be fair, we need to first read the snapshot file, right? So we need to read the snapshot file. Because of that, we probably need some sort of a function, right? So you have dump snapshots, but you also need to load snapshots. So here we're going to have a file path, and in here we're going to have the list of dictionaries, right? So we have a list of dictionaries like so. So with open file path, to be fair, I think the replay should accept only by file, right? So it's going to be iterating through things in the by file and comparing only these things. Right, and recording is going to be happening through the list file. I think that makes sense, right? So I think that in fact makes sense. I don't know, we'll see. So here we are opening it for reading in binary, right, as f. So, and basically we do the opposite situation, so to speak. So is there any way for me to know that we reached the end of the file, right? So I can probably check something like while f. Is that going to work? Right. So is that a good way to check that we reached the end of the file or something like that? I think that's it. Anyway, there's no null terminator there. But I mean, I'm not talking about null terminator, I'm talking about the stream. Can stream answer a question where you reach the end of the stream? I don't know, we'll see. Okay, so let's just like try to do that and see how it works. Anyways, so here we need to have a snapshots. We need to read the snapshots, and this is going to be something like that. So, and we need to read the blob, right? So we're reading the blob. The first blob that we want to read from F is going to be shell. So that's basically the first thing. What we're going to do is we're going to save it to the shell. Then we're going to read int and it's going to be return. Can I actually use a little bit of a Emacs magic? Chat, in 2024, can I finally use a freaking Emacs magic? In 2024, let's just grab this entire thing and just select it like that and just replace it with read. Just replace it with read. But then we're going to take this kind of thing, we're going to put it in here, and we're going to say it's equal, then we're going to turn it into actual variable name that we can then easily use to construct the dictionary, right? So we're going to do snapshots, append, right? So, and in here, we're going to just append that specific dictionary, hopefully. The reason I'm doing it like that is because I'm not sure if I just call them within the dictionary, they're going to be called in the right order. I'm really not sure about that, so because of that, I'm just doing it like this. Boom. Can your Vim do that? Can your Vim do that? Can your Vim do that? That was kind of weird. Something with my voice again. So snapshot, snapshots. Yeah. So this is basically what I want to do in here. So in here, I think we have to actually accept test by format, right? So this is going to be test by, and I want to load snapshots from test by, and then we can simply print this entire thing. Let's go ahead and print it and see how it's going to go. All right, so I'm replaying. Okay, so this has to be by. No, it has to be test by. All right, list by. Okay, assertion failed. Cool. Which assertion failed specifically? That's actually a very interesting question. So it's probably somewhere at 10. So we did not manage to actually read shit, surprisingly. And at which line we didn't manage to do that? That's a good question. There's no information, for fuck's sake. So can you actually have an additional information in assert, right? So hello, if I put hello in here, for instance, is it going to tell? Okay, so that's pretty cool. Can I now say for example, the name of the field, and the name of the field is going to be just like field? Can I do something like that? The field is a shell, right? So, so, and something with the shell didn't work well. But which one? So if I take a look at the B shell, maybe, so when I read the blob, so shell return code std out, shell return, where is the reading? Yeah, I don't really see what's up with all of that. I don't really see what's up with that. So everything seems to be okay. Maybe it didn't properly indicate. Yeah, so that's probably what happened. It probably didn't properly indicate the end. So if I actually put this thing into a separate variable, snapshot like so, and every time I manage to parse a single snapshot, I print it, I'm pretty sure it will print all of the snapshots, then it will fail at the last one. So that's kind of weird. How do we know that we ran out of the... You know what? I feel like we can't know that. And the only way for us to know that is to bake that information into the file. Honestly, that's the only way to do that, right? So essentially, when we are saving, we dump in the snapshot, what we have to do, we have to write an int, and let's actually say this is going to be count, right? And the count is going to be simply a length of the snapshots. So that's basically going to be the thing, right? That's basically going to be the thing. So, and then using that count, we're going to be actually reading all of that. So let's actually record, right? So, oh shit, that was bad. I used, okay, so it's kind of funny. Yep. So that's probably why I should actually accept the list file, and the by file should be computed based on the list, because I want an easy way to switch between record and replay without switching the file. That's a very important actually UX issue, right? So that's probably why I should not directly accepting this thing. The name of this thing should be computed based on this stuff, so we can switch between record and replay. Okay, so nice to know that I need to do that. All right, so we'll get that. So, and then here, if I open this thing now, as you can see, the first thing here is the amount of tests that we have in here, and then come the rest of the tests. Okay, so that's cool. So now, when I'm loading the snapshot, the first thing I want to load in here is going to be n, right? So essentially, we are reading the int, right? So this is the count, and in here we just do for I in range count. Maybe we can even ignore this entire thing, and yeah, there you go. So afterwards, I want to replay, but I have to put by here, and we managed to successfully actually parse all of the cases in here. We managed to successfully parse all of the cases in here, right? So that's kind of cool. That's kind of cool. Yeah, very simple format. I really like it. I love simple but effective formats. That's what I like. Okay, let me now see, let me now fucking see, let me now fucking see, let me now fucking see. So we are basically doing these things, so we're computing the by. So now what you have to do, you have to provide the list file, and we're going to compute in the list file based on that, the by file based on the list file. So here's the snapshots, right? So here's the snapshots. We can now take that snapshots like so, and as we iterate in them, we have to do, yeah, we have to do the replay, right? So that's what we have to do. For snapshot, right? For snapshot in snapshots, what do we do? What do we do? We take the shell and we just run it. So we can use the subprocess run, and we're running it through the same basically shell. So it's going to be sh, c, and just that shell. But on top of that, we're going to be capturing the output. Capturing the output is going to be true. There we go. So, and here we got the process. Look at that. So we'll get the process. So the only thing that is left to do in here is literally compare the process return code, right? Return code and the expected return code. We can try to assert them, but maybe it would be nicer to actually print what exactly is going on in here. So if the return code is not what we expect, right, we have to print something like, so unexpected return code, right? So unexpected return code. We basically should probably print just the shell, right? So this is going to be just f, and this is snapshot shell, snapshot. All right, and then what we can print in here, 1, 2, 3, 4, expected, this, so snapshot return code, actual something else, and it's going to be actually process. It's kind of funny that snapshot, oh, you can't do it like that, fuck, because snapshot is not an object. You can't do it like that. It has to be something like this. But is it going to work with f strings? Does anybody know? But I mean, if it doesn't, I can just do something like this. Yeah. All right. So I have like a double quotes in here, so I can have single quotes in here. All right, right. That explains it. So also this kind of stuff is not going to work because they're dictionaries. They're dictionaries. Okay. So this is a snapshot, blah, 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 blah. Data classes, what I found while working with ports is that data classes made my code slower for whatever freaking reason. So anyway, we're gonna do exit one. So, and as we work with this kind of thing, maybe what we can do, we can actually print the shell, right? So replaying, so this is going to be like this. So this is F, and we are replaying the shell, So since we are printing the shell, we don't really need to print it the second time, right? So maybe we can just say an expected return code. So replaying this thing, then we got an expected return code. We just scream about it and then we just exit. So, right, I think that makes sense. So if I try to now replay the whole thing, right, it's complaining about something. I didn't really understand what. Yeah, I forgot to close this thing. So what else do we have in here? Yeah, so that also makes sense. All right. Okay, so, and we still print, when we load the snapshots, I still print each individual thing. Yeah, so we don't really have to print that anymore. Yeah, replaying that, and replaying that, and so on and so forth. Okay, that's pretty cool. That's pretty cool. So now, but the problem is we are replaying kind of like the whatever was saved in the original thing. I'm not sure if that's a good idea or not. But anyway, so the next thing we need to do, we need to compare process std out with the snapshot std out. And the cool thing that I have in Tula specifically, as I already said, is that it can show you the diff. But I think Python had like a diff lib or something. Like I remember a long time ago there was, yeah, I think it's a diff lib. So we can try to use that to compute the differences between the standard output of one thing and another thing. So yeah, I think that's a good idea. So does anybody know how to use this shit? All right, so you have a bunch of things. You have a bunch of like lines in here. Then you do context diff, and yeah, from file before. So it's kind of weird. And can I just easily compare? So okay, so end diff. Ooh, that's kind of cool. So end diff, maybe that's what we want. Can we do end diff? If I literally import from diff lib import, let's just import diff lib, and I take a look at the help of diff lib. Do we have end diff? And okay, return data with the difference between A and B, list of it's a list of strings. But what if I just have strings instead, right? So if I do end diff hello world, and then I'm gonna say foo bar, right? Diff lib. So it returned a generator, but if I, how do you print that thing? Yeah, you have to join them, right? You have to join them. Okay, so let's join this thing. Oh, right, and that's kind of bizarre. That is kind of bizarre. Keep. So you, yeah, so they split them by new lines and they keep this kind of thing. So I suppose they really need to be like this. Okay, I see. But what if I join them with new lines? And then I print those things. Yeah, that's basically what's going on here. And if I have maybe hello, right? Well, I mean, it's just like that. So then here I have test, and at the end in here I also have test. I suppose what is, yeah, it's going to just like keep the test like this. So that's basically what we have in here. That's basically what we have in here. But does it show everything? I suppose ndif will literally like show everything. And the context diff, right? If you do context diff, it will show you only the like a few things. Compare energy context, a compact way of showing just the lines that have changed, plus a few lines of context. Okay, so and the reason why I want to use like a library for diffing in here is because hopefully that will make the script more cross-platform, in the sense that if I just call to the separate diff utility, maybe it's not present on Windows. But to be fair, on Windows, the development environment is basically Linux anyway because of WSL. So these days, you can just like assume the Linux environment and you're going to be safe in the majority of the cases, right? So majority of the people develop on Windows through WSL anyway. So Linux is the best development environment even on Windows. I'm just telling you. It will be interesting to code the diff utility. We already did that. So some time ago we did piff. But it's actually kind of like for files specifically. All right, so, and it doesn't output a readable format per se, right? It just outputs a patch format that you can use, right? It uses custom formats. So we implemented it just to learn how to do this kind of algorithms. It's not particularly convenient to use for what we need diff tool right now. All right, so we got some sub. Thank you so much, Ian Nertson for tier 1 with the message Molodets. Thank you. And anonymous gifter, thank you so much for gifting the sub. All right, so yeah, that's what we can do in here. But that means I have to take the standard output. And actually convert it to string and split by lines. So interestingly enough, what if I, in both of these cases, have actually list of bytes rather than the list of strings, right? So what if they're bytes? Is it, okay, they have to be strings. Okay, so that they have to be strings. Oh boy, right, so if I have something like this, how easily can I convert that to a string? Right, that's not really a great way. So I suppose I have to use something like encode. Encode is not defined. All right, so let's go ahead and just Google up Python decode. You think it's a decode? Okay, so it's a decode. All right. So Python string to bytes to string. Stop debating me, chat. Stop debating me. Okay. Convert bytes to string. All right. So what do we have in here? Hey, why don't you fucking load the answers? Stop. Okay, so it's decode. Oh, it's a method decode. You didn't tell me that, chat. All right. So decode. All right. And by default, I suppose it's going to be using UTF-8, but it looks like we didn't have to actually provide UTF-8. Okay, so that's cool. That's cool. So we have to decode it, and it's kind of annoying that it has to be UTF-8, so it will make it less useful, right? Because if we could just work with bytes only, we could work with the things that output binary format. But I mean, supporting binary format could be a separate work, right? So separate feature, so to speak. So because right now it's easier to just compare the strings, right? So yeah, we're gonna keep in mind that maybe we want to actually support binary formats, but we're not gonna do it right now, right? We're not gonna be doing right now. All right. So difflib, right? So this is a difflib, and what do we have in here? So if they are not equal to each other, so we're going to be doing a context diff. Context diff. So example. All right. So I'm not sure about this from file thing. It's kind of dumb, honestly, but whatever. Oh, it's needed for these kind of things. Okay, I see. And it doesn't use the universal format. It uses slightly different format. Really? Like, it uses these bullshits? I guess it's fine, but I mean, it's kind of annoying, honestly. Because that and diff used like a proper thing, but this one, let me read about it. Return delta, a generated delta tile. Okay. Our compact way of showing just lines by default. The modification times are normally expressed. It's annoying if it's not going to be using like this plus minus format is gonna be extra annoying for me, to be fair. All right, extra fucking annoying, but it is what it is. All right, so from diff import context diff. Why do they have different formats, right? Depending on the function, it's kind of bizarre. Anyways, so what do we need? We need to take we take this thing, we decode it as UTF-8. So we're making like a really wild assumption in here, right? And we split by n. So they also use split somewhere there, right? So they also use split. But if I do n diff, like where was there was example actually. So there's a split lines. So this is probably what we want to do. We want to split lines but keep the ends. Right, we're splitting the lines but keeping the ends. That's what we want. All right, so this is the first thing. We decode it into UTF-8. We split the line, keeping the ends because that's what it wants apparently. Anyway, so now we're doing the same thing for the snapshot, like so. Right, so this is going to be B. And we print the following thing: unexpected std out, and we just do context AB for line in, and we just print that specific line. So that's about it. So we can even copy paste this entire stuff for standard error now. And might as well, I mean, I'll have to explicitly now do something like std error. All right, and I forgot, after all of that stuff, just exit with 1. Furthermore, maybe it would make sense for me to print OK at the end, right? So this is basically going to be OK. So that's about it. Yeah, so we can try to replay now the whole thing. So and see how it's going to go. Unexpected standard error, and it didn't print shit, right? So, I mean, standard error is expected to be 0. So I don't really know what the fuck are you saying, why it is not. Oh, I see, standard error. Did a little bit of a fucky-wucky and potentially oops. Okay, everything is fine. So everything is in fact fine. Everything is fine. So it makes it kind of difficult to modify some things, but we can try to, like, because I can modify some of the strings, right? So we have 19. This is 19 characters. I can maybe, right, so the output is 13. So here is 12 plus 1 new line. Okay, if I change full bar in here, or maybe just something like this. So this is basically 9 plus 1, 10, right? So you see, even though it's a binary format, it is extremely easy to modify. And that's kind of the point, right? So it's extremely easy to modify. Right, so, and now if I try to replay this entire thing, now what it says, right, unexpected, so replaying that specific thing, unexpected standard output, and absolutely horrible diff format. So yeah. So there is a unified diff apparently. Okay, so unified diff, but is it compact? Right, so are a compact. Okay, so let's actually use unified diff then. So thank you so much. I hope you're not debating me yet again. Context diff, unified diff. All right, so do it one more time. All right, that's way better. That's actually way better. Yeah, replaying this thing, unexpected standard out, and yep, that's basically what it is. That's basically what it is. Furthermore, we can now try to record the whole thing. We just captured and record everything, and we can try to replay one more time and replay it. So okay, kind of looks ugly. I don't like it, so let's actually remove okay. Okay, that's pretty cool. That is very, very cool, meine Freunde. Very cool. Very fucking cool. So you know what that means? That means we can finally go ahead and try to apply this tool in Tula, for instance, right? So in Tula, I have a custom, like a shell-based thing. But I think I can very quickly migrate to Riri, right? I can very quickly migrate to Riri. So essentially I have a test list in here, right? So, but it actually has like a CSV. So it basically tells you what kind of subcommand for cargo to run, whether to use run or whether to use expand, right? So expand just expands the expression just to test the output and stuff like that. So I'm pretty sure I can simply use something like this. I can just take this entire stuff and I can say, okay, run cargo, run, do a quiet mod, right? So as a quiet mod essentially doesn't print the, how is it called, like a splash, right? So, and doesn't print the compilation log or anything like that, it's just being quiet. Then we print the corresponding subcommand, right? And then we run all of that on the corresponding file. So that's basically what we're doing, right? If now so do I have Riri in here? So here is Riri. Now if I try to record tests list, is it okay? So it is now capturing the outputs of all of these things. All right, that's pretty cool. So it captured the outputs, all of these things, and it created a 41 kilobyte file, right? So it ran all of these things, and there is a lot of expected outputs. But like you see, it already worked. I'm using it in one of my projects. I'm just like already using it, like it's in production. So it also has, I'm also testing the errors and stuff like that, right? So I'm testing like expected errors. So here, for example, this is supposed to fail, and this is the expected error in here, right? This is expected error. Yeah, that's pretty convenient. So now I can try to maybe replay this entire thing, and it's replaying all of them, and it's just like, yeah, it's pretty cool, and it works. So we can try to maybe do a little bit of modifications in some of these things. For instance, I don't know, I can swap around some of the lines, right? Because the program actually print traces in the same order as they are in files. So the easiest way to break something is to just like swap these things around. So, and that will automatically break the whole thing. And as you can see, it actually broke it. So it tells us where exactly it broke, and it tells us exactly what's going on in here. So there is a little bit of extra lines in here, which is not particularly convenient. So one of the things we want to do in Riri, I suppose, so is when we're printing all of these things, we don't want to print the ends, I believe, right? So the thing, oh my God, Emacs. The thing we want to do in here, we want to put end like this, because I suppose the unified diff just like, yeah, there we go, that's much better. So that's pretty convenient, actually. That's extremely convenient, honestly. Right, so this is a plus, and yeah. So maybe, so they also have this like from file to file thing, right? So maybe it makes sense to actually utilize that somehow, so we know what is expected and what is actual, right? What is expected and what is actual. So where is the unified diff? Where is the, here is the unified diff. So from file is going to be, how can I call it? So expected. So it's actually actual, to be fair, right? Because A, if you look at that, A is actual and B is, we need to swap them around, honestly. We need to actually swap them around, like so, A and B. A is expected and B is actual, right? So when we compare them, they're going to be viewed as such, right? Expected to file actual. All right. So if I try to now run this one more time, does it tell us? Okay, so expected actual. All right. So remove that, but then edit this stuff in here. So we can clearly see that, like, what was modified. It's perfect. So, but now if I essentially remove that modification and try to run it again, it still passes, right? So it's kind of cool. It's like a drop-in replacement for whatever I was doing already. And since it basically expects the list of shell scripts, right? You can use it pretty much for anything, Right, you can use it pretty much for anything. This is actually super convenient. So I was modifying Riri in a Tula folder. So let me actually go to my Riri folder, and I suppose the time has come to maybe do a committee for this entire thing. Right, so I'm gonna just copy paste it in here. There we go. And the license, I'm gonna release it under MIT license. Right, so we're gonna be doing git ignore. And we definitely need to ignore this Python garbage, right? So we really don't need this kind of Python garbage in here. We really don't need that. So in here is just an example of this entire thing. Right. So let's actually write readme. Okay. Riri pi. Let's go like this. Maybe I'm gonna say record. Replay. There we go. So universal behavior testing tool in Python, right? Something like this. So quick start. Create a file with a shell command line per line, right? Maybe we want to actually turn this into the example, right? So maybe we want to turn this into example. So there we go. So I'm still not quite sure how I want to approach this entire stuff. I'm really not sure, because when we are replaying, we're actually using by, right? And if I modify something within examples, I'm not replaying actually examples, but I'm still passing this as an argument, which is not particularly convenient. But maybe I can actually resolve that a little bit later off screen already, so it doesn't really matter. But that would have been convenient, honestly. That would have been convenient. So because what I could have done is I accept the original list file with the shell script, right? So I accept the original list file with the shell script. I run whatever I read from the list file, but I then look up the expected return codes and standard outputs in the by file using shell as a key, right? But that means that I now need to be order independent, right? So what if the order of this thing changed, right? So that's what makes it kind of inconvenient. What if the order has changed? So that's the problem. Like, I don't really know how to do that. So I want to keep it simple, right? I really want to keep it simple, but at the same time, I don't freaking know. I don't freaking know. Okay, so create a file with a shell command per line. Let's call it something like a test list. Then what you're supposed to do, you're supposed to do console Riri pi test list record. First, second is record the expected behavior of each command, of each shell command, like so. All right, so 3, maybe something like the above command should create test list by file with with standard output, standard error, and return code. Captured as the expected behavior. Yeah. All right. Replay the command lines, checking their behavior against the recorded one. Right. So this is basically how I want this tool to be used. Right. So it would be also kind of nice to document the format itself. Right. Yeah, but I think it's fine for now. I'm gonna add more documentation a little bit later. So let's do git init, right? Git init, like so, and let's commit everything we have in here. Maybe I'm also gonna include like a test list or something like that. So ready, set, go. Let's go, and let's create a repo. Change record. So did I make a mistake? Record, yeah, replay. All right. Typo. Okay. So, and I try to keep the format intentionally simple. So if you don't want to use Python, you can quite easily implement it in whatever language you want. Alright, user behavior testing tool in Python. So this is going to be public. And I'm going to copy paste the remote thingy. Add origin. Boom. Right, I'm going to push that right into the repo. Like so. So it should be available already in here for everyone who's interested, and for people on YouTube, it is going to be available in the description as well. So I also want to add a couple of other things in here, right? So for example, link to porth, right? So because this is where we got the parser and serializer for the by format. All right, so did it actually push? I think it pushed. All right, that's cool. All right, so I guess that's it for today. Thank you so much, Royal Flush Guy, for the sub with the message. Hey, Soding, hope you're well. Have you ever tried out LOL code? No, I don't even know what it is. Thank you so much for the sub. All right, so that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all on the next recreation programming session with Mr. Azuzin. I love you. Mwah.